Hello, everyone. As you've hopefully noticed, that person standing in front of you right now is not me. I am in the great city of Newark, New Jersey. Uh, but just because I'm not here doesn't mean we can't get some good math done. So, what's going to be happening is you're going to watch a video, sort of moving on to our next topic. It is very much related to those systems of equations we have been doing. We're going to be looking at systems of inequalities. So what's going to happen, I'm going to have a short little video for you to watch. Then you'll work on practice 12 for homework. And then you guys work tomorrow, you work Friday. So I will see you on Monday. And on Monday, practice 12 will be due. And we'll talk about sort of what's in this video. Oops. And the problem of the month. So we're going to start just with systems of inequalities. So question is to graph the system of inequalities. First thing we got to do is remember, how do we graph an inequality, right? Just one, never mind the system. Well, it's very similar to graphing a line. So we'll do this first one. Let's do this first one in red. And just like when we graph lines, we're going to look, so think about our slope-intercept form here. So our y-intercept is -5. Let me scroll down a little bit. This is -5 is our y-intercept. Our slope is -2. Well, we don't have any space to go down to, so we'll go up to left one, to left one, to left one, to left one. Now here's sort of the first thing we got to remember. If you remember with inequalities, the type of line we draw is very important. So this one, we have y is greater than, strictly greater than. So our type of line, we're going to have a dashed line. Right? So draw a dashed line. Let's get a nice red line to match. Make sure it's dashed. We'll draw a dashed line going through there. So that's the first thing you got to remember with inequalities, right? Either a solid line, or a dashed line, if it's strictly greater than or less than. And we also need to remember that there's an infinite number of things that can make this inequality true. So if you remember, we got to shade in one of these two regions. Well, how do we decide which region to shade in? We just choose a point, plug it in. If it makes it true, that's the region we do shade in. If it makes it false, we want to shade in the other region. So as long as the line is not on this point, I always use this point. There's a point. There's 0. Easy point, I think, to plug in. So we plug in 0, 0. So this equation here, that gives us 0. -2 times 0 is 0 on this side. So it's greater than -5. Well, that is true. Right? That is a true statement. 0 is greater than -5. So the side with 0, 0 should be shaded in. So for this red line, shade in this direction. And shade that side with the 0, 0. Okay. And we're going to graph that other one. So I'll draw this one in blue. Well, this is in standard form, so we'll use that cover-up method. So we cover up x. So y-intercept would be 3. If we cover up y, our x-intercept would be -2. So y-intercept 3, x-intercept -3. And then we look at that inequality. This is greater than or equal to. So this one, we're going to have a solid line. So we'll go up here, choose a line, let's make it blue. And this time we want it to be a solid line because it's or equal to. So we'd have this line coming down here. Get rid of that little extra mark there, that little one. And we want it to be a line, so we'll have arrows. Now we have to decide which way to shade in for this one. So again, we're going to plug in 0, 0 because it's not on that boundary line. -0 is still 0 plus 0 is less than 3, or less than or equal to, sorry, 3. Well, 0 less than or equal to 3, that is also true. So for the blue line, we will also shade for 0, 0. Okay. Now, just like with systems of equations, with systems of inequalities, our solutions, in this case solutions, because there's an infinite number of them, is anything that makes both of these true. So it's going to be the region that we would shade in for both of these individual inequalities. Well, that is going to be this region. So this would be the region that we shade in. So any point in this region would make this system true. Any point in this region would be a solution to this system. So for example, 0, 0 would be a solution to the system. This point right here, 1, 2 would be a solution. Point right here, or that 1 million. And these points on the dotted line, what do you think? Would that be a solution or not a solution? You're right, not a solution, right? Dotted line means we can't have that as a solution. How about on the solid line? What about this point, negative 1, 2? Right, exactly, right? That would be a solution because it's on a solid line. So this has an infinite number of solutions, and since we can't possibly list out all those solutions, we graph it. Right. All right, so let's take a look at an application of this. So we're going to look at one problem, and then you guys are going to be able to start that practice 12. So this is the problem I want us to look at. You have a summer job. You have 2 part-time summer jobs. Waiting tables, which pays $10 an hour, and mowing lawns, which pays $12 an hour. You would like to make at least $240 a week, but you're only available to work at most 40 hours per week. Graph all possible combinations of hours you could work and list 4 possible combinations. So, first thing that jumps out to me are these phrases at least and at most, right? That's what's telling me, okay, this is going to be an inequality, a system of inequalities. And then just like the system of equations, first thing we want to look for are variables. So you want to figure out the possible hours you could work for each job. So we'll have one variable for hours in tables, one variable for hours or lawns. Okay, and then we want to try to write our inequalities. So this is what I want you to do. I want you to try to write these inequalities on your own. So pause the video, see if you can try to write the inequalities on your own. Ask people next to you, that's fine. And then once you think you got it, you can unpause the video, and I'll talk through it. So you should pause the video now. And we're back. Great. So the inequalities, again, just like with equations, we want to look at the 2 totals. So total $240, a total of 40 hours. So let's do the dollars first. Do that dollar ones first. So you want to make at least $240. Well, you get $10 every hour that you wait tables. You get $12 every hour you mow. So if you want to know how much you make total, you have to add them. Now this is the part that throws a lot of people off. You want to make at least $240 a week. At least $240 a week. Which means 240 should be the smallest amount of money you make. So 240 should be less than or equal to the amount of money we're taking in. All right. Then let's look at 40 hours. Right? We looked at dollars. Now let's look at hours. So you can work at most 40 hours. Well, you're working W hours waiting tables. You're working M hours mowing lawns. Figure out the total. Just gotta add them. You want to work at most 40 hours. So 40 should be more than anything you work. Right? You could work 29. You could work 35. Right? You don't want to work more than 40. So 40 should be greater than or equal to anything you work. All right. Now we're going to want to graph these. And you'll notice I made on our graph over here, sort of switched up the scaling, right? If you think about that cover-up method, I'm going to need 40 on each, so we're at 40 squares. So I made each box worth 2 there. Made each box worth 2. So let's sort of start to walk through this. We're going to graph that red one, right? My W-intercept will have this be our W axis, this be our N. Our W-intercept for the red one, we cover up M, be 24. So 24. Our M-intercept would be 20. So we got our 2 intercepts. Now we want to draw a straight line. Since it's equal to, we're going to have a solid line. Get red to match. We'll draw that line. Great. I gotta think about, okay, which way should we shape? Well, again, plug in that one. There. So if I plug 0, 0 into this equation, inequality. If 30/40 is less than or equal to 10 times 0 is 0, plus 12 times 0 is 0. 240 is less than or equal to 0. Is that true? No, that's false, right? So 0, 0 should not be on the shaded side. So we're going to shade the other region, shade up and away. Then we want to graph that green one. So cover up and away again with W-intercept is 40. W-intercept is 40. M-intercept is 40. This one was also or equal to, so this will also be a straight line. So let's get a nice green straight line. Let's try that again. There we go, a nice green straight line. And arrows. We gotta plug in to see what makes it true. So again, I'll plug in 0. So if we plug 0, 0 into this, we get 40. Greater than or equal to 0 plus 0, 0. True. This one, we can shade 40. So we have this. Now to figure out the region or the possible combinations that will make this true, we just got to shade in the region that has both sets pointing. So it would be all this stuff in the middle, right? Sorry, it's a little messy. I'm trying to use my mouse to do this. So all this area in the middle. So any of those points in that region would be a possible combination. So anything in that region will be a possible combination, right? So for example, this right here would be a possible combination. 10 hours rowing and 20 hours waiting tables. Or over here, right? You could do 20, or what's that? That's 18 hours mowing and 14 hours waiting tables. Right? All of these points inside here would make both of those constraints. Right? It would make them at least $240 and be less than, or at most, 40 hours. Great. So from here, try that practice 12. There's some application problems in there. A lot of practice with graphing systems of inequalities. If you have questions, ask the people around you, or you can shoot me an email. But otherwise, I will see you on Monday. Have a great day at work tomorrow and Friday, and have a good one.